Hello guys, hope you all are doing well. So in the continuation of the previous GATE series, we are solving the questions of GATE 1993. So today we will solve section B and within two lectures, within two videos, I will complete section B. So today we have a new question. So without wasting time, we will look into the question. This is from fluid mechanics. Topic is viscous flow. A laminar flow is taking place in a pipe of diameter 200. So we have diameter of 200 mm. Maximum velocity is 1.5 meter per second. So maximum velocity, sometimes it is said center line velocity. Maximum velocity or center line velocity. Center line velocity. Okay, maximum velocity or center line velocity. Find mean velocity and the radius at which this occur. Okay, so we have to find the u average and the radius at which it will occur. Also calculate velocity at 4 centimeter from the wall of the pipe. Okay, from the wall. Okay. So we have to find out the mean velocity and the velocity at 4 centimeter from the pipe wall, and also we will find the radius at which mean velocity will occur. Okay. So at any location in a pipe, if you find the velocity at any location in a pipe, we have this formula. Okay, this r is constant radius of pipe. Okay, this is pressure gradient, this is radius of pipe, viscosity of the fluid. Okay, so if you want to find velocity at any location, put that value here. Okay, so I can write this term as Umax. This is the value of Umax. This is okay. So note it down. This is Umax. Now, where Umax is equal to 1 upon 4 mu minus del Py del R into R square. Okay. Now, for laminar flow, we know that U average upon Umax is equal to 0.5 or Umax upon U average equal to 2. Okay, so we have Umax or center line velocity, this, so U average will be this. Now, we want to find the radius at which this occur. If I will put this value here, okay, and calculate this R, then this will be the value of the radius at which this velocity will occur. So we will do the same. Radius at which mean velocity will occur. Okay. So I have put it Umax here. Okay. U at any radius. I want the radius at which U mean occur. So I will put Umax, U average here. This is Umax we have. So just putting all the values and calculating. R will be 70.7 mm. So at this radius, the mean velocity will occur. Okay. U mean will occur. Now, velocity at 4 centimeter from the pipe wall. See this figure. This is diameter. This is the radius. Always remember the terminologies that the distance from the pipe wall we called as y. A very good question from this concept in GATE 2016 had GATE had asked. That question was very conceptual. If you don't know these terminology, you cannot solve. So distance from the pipe wall we designated as y, and from the center line to the pipe wall we will designate it at r. Okay, now I can write this greater like radius of the pipe is equal to y plus r. Now putting values of r and y, we will get small r is equal to 0.06 meter. So we have this formula again now. Okay, this formula. I want to find the velocity at this radius. So I will put this value here and we'll go for the velocity. So we'll do the same. This is Umax. So I put it the value of Umax. So calculating velocity will 9.6. the velocity at radius equal to 0.06 is equal to 0.96. Okay, this is the same location from the pipe wall at this. Okay, so if you have any confusion or anything in this question, just comment it below. I'll reply as soon as possible. Okay, going to next question. A pipe of diameter 20 centimeter and length 10 kilometer is laid at a slope of 1 in 20. 1 in 20 means this 1 in 20 means at every 200 meter, at every 200 meter, the slope of the pipe is raised by 1 meter. Okay, so this angle will be very small, less than 10, I think, or could be 5. Okay, an oil of specific gravity of 0.9 and dynamic viscosity 1.5 oils is pumped up a rate of 20 liter per second. So we have Q. Find the head loss due to friction. Head lost due to friction and power required to pump the oil. Okay, so very first we will see the figure. This, okay, fine. So see, radius is 0.1. Okay, so diameter is 0.2 meter, so radius will be 0.1 meter. Okay, head loss due to friction and power required to pump the oil. Okay, so very first we will calculate the Reynolds number. Since it is a, we will see whether this is laminar flow or turbulent flow, because is the question is not mentioning anything about the flow. So putting all the values, rho Vd, rho is 0.9. Okay, I can write it there, rho into V mu, rho into D, because we have density 900, diameter mu, V we don't have, but we have Q. So in the term of Q, we can write the Reynolds number. Velocity is 4Q upon pi d square. D and D, 1D will cancel out. So this is putting the value of Q as well here. So we will get Reynolds number this. Now, for laminar flow, fanning friction factor is equal to 16 upon Reynolds number and Darcy's friction factor is equal to 64 upon Reynolds number. If you will equate these, so it will become 16 upon FF is equal to 64 upon FD. So 16 4 ja. So Darcy's friction factor is equal to 4 into fanning friction factor. As I said earlier in the 1990s questions, when we were solving that, I told you that this, always remember this. Okay. So on the basis of that, we will solve, on the basis of fanning friction factor, we will solve the question. But remember this as well. Okay. Many people don't know the relation between Darcy's friction factor and fanning friction factor. Okay. Okay. So head loss due to friction is given by this. Head loss due to friction is given by this. 4FF. This is fanning friction factor. If you want to calculate as Darcy's friction factor, then you will replace 4FF into 4FF with only FD. Okay. So putting all the values, we will get head loss due to friction. This is our first answer. But power required to pump the oil. The head due to slope will also contribute when we will calculate the power. So slope into length. So head due to slope will be 50 meter. Now power required to pump the oil, rho GQH head total 900 into 10 into 20 by 1000 into 85.11 plus 50. So 24.3 kilowatt is the power required to pump the oil. Okay. So if you have any confusions, just comment it below. Now going to next question. Determine the value of Kc that will give the 60 degree of the phase margin. Okay. So we have given with the phase margin. This time phase margin is given. Okay. The diagram is given to us. This is plus, this is minus, and this is C, S, this is RS, RS. Okay. So now value of Kc at 60 degree phase margin we have to calculate. Phase angle equal to this formula we have. If you are following Donald R. Kufner or Stockner-Bolus, then you will find this formula. Okay. Now, putting the value of phase margin, we will get phase angle 120 degrees. So now we will calculate the phase crossover frequency on the basis of the phase angle minus 120 degree. Now, calculating the phase of all process. So phi is equal to minus 2 tan inverse omega. This is crossover frequency. As okay, at omega equal to omega crossover, phase is equal to minus 180, but because phase margin is 60, omega will become minus 120. So putting this value, we will get omega equal to 0.3. Now, amplitude ratio is this. Okay, I have calculated the amplitude ratio. Now, at omega equal to omega crossover, amplitude ratio become 1. So similar concept, I have put it the value of 1 and omega equal to omega crossover. So the value of Kc will be 4. Okay. So if you have any doubt, any confusion, just comment it below and I will reply as soon as possible. And in the next video, we will complete the 1993 solutions. Then we will go to 1994 and hopefully I'll try to upload till 1999 because 2000 onwards there are questions which are short answer type. So these are not lengthy as we have in 1990 to 1999. Okay. क्या कह रही है बच्चा हाँ okay so take care guys, bye guys, and if you have not subscribed to my channel, it is just a request that if just subscribe to my channel and like okay, bye guys, take care.